Hello, my name is Celal Furkan Çevik. I'm a first year electrical engineering student at Bilkent University. In this video, I'm going to present my Physics 102 project. The title of my project is Experimental Investigation of Factors Affecting Capacitance. So let's start. The aim of this experiment is to investigate the factors affecting the capacitance value of a parallel plate capacitor. So first of all, what's a capacitor? A capacitor is an electrical device that stores charges. It is a critical component in electronic circuits. In this experiment, we will use a parallel plate capacitor. When voltage is applied between its plates, one of its plates will store positive charges and the other one will store negative charges. This is the relation between the amount of charge stored in a capacitor and the potential difference applied on that capacitor. The constant C is called the capacitance of the capacitor. Its value can be determined by using this formula. In this experiment, we will observe two factors in this formula. In the first part, the distance, and in the second part, the dielectric constant of the material between the plates. And these will be our constants in our calculations. This is the experiment setup that I built. I created two metal plates and I stick them to two different books so that I can arrange the distance between the plates. Let's start with the first part. In the first part, I observed the distance between the plates, and this is the capacitance value for 1 millimeter distance between the plates. And here, the distance is 2 millimeters, 3 millimeters, 4 millimeters, 5 millimeters, and finally 6 millimeters. Here is our results for the first part and the percentage errors. This is the graph for the first part. Looking at this graph, we can see that as the distance between the plates are increasing, the value of the capacitance is decreasing. In the second part, we will observe different materials between the plates. For example, this is glass. This is wood. And here are a bunch of papers. Here are the results for the second part. Here is the graph for the second part. Looking at this graph, we can compare the dielectric constants for these three different materials. And we see that wood has the highest dielectric constant, then comes the paper, and the last one is glass. So let's take a look at our results. In the first part, we saw that as the distance between the plates increases, the capacitance value decreases, and this result is totally compatible with our theoretical expectations. And we made some error measurements and we recorded up to 25% errors, and this value is not a high value for this kind of experiment because the setup is hard to use. And then comes the second part, and we compared different dielectric materials, and we saw that wood has the highest dielectric constant. Then comes the paper and glass, and we expect this to happen when we look at theoretical values of the dielectric constants. Maybe glass could be a little higher, but as I said before, the experiment setup is hard to use, so this may be attributed to different kinds of errors, such as the gap, the mismeasurement of the gap between the plates, and so on. So this is not a problem for this kind of experiment. So at the end, it can be said that this experiment is successful. However, it can be improved by doing more careful measurements and using more improved lab materials. So this is the end of this experiment.